Let's say we have this graph. The critical points give us possibilities of finding like the relative maxes or the relative mins. The ends of the interval give us other possibilities of finding a max or min. And for this lesson, we're focusing on absolute maxes, absolute mins. In the previous lesson, we did relative mins and relative maxes. And this is very similar. All you do here is also include the endpoints. As you see here, if you look at the critical points, it's a critical point right here, critical point right here, critical point right here, critical point right here. In this case, this critical point is the absolute max. Um, and however, the absolute lowest is right here at an endpoint, which isn't a critical point. So when you find the absolute maxes or mins, you have to test not just the critical points, but the endpoints on your interval. So the candidates for absolute extrema on an interval is your critical points and your endpoints on where they can potentially occur. You have to test all of them. So let's do an example problem. Find the absolute min and the absolute max and the absolute min of the function f of x on the interval -1/2 to 4. Remember to show that you checked all the candidates. So find the derivative. F prime of x is equal to 3x squared minus 6x. Because all we're doing here is just finding the critical points. Set it equal to 0. 3x times x minus 2 is equal to 0. So you see the critical points here are x is equal to 0 and x is equal to 2. We want to find the absolute max and the absolute min, like the output of the original function. So you see we have to test 4 points, the -1/2, the 4, the 0, and the 2. So f of -1/2, that's your beginning of your endpoint, your last endpoints, f of 4, and you have the two critical points, f of 0 and f of 2. So all you do here is plug all these values into your original function. Whatever output is the highest, that's your absolute max. Whatever is your lowest, that's your absolute min. So I'm going to save some time, but if you plug these all into the calculator for f of x, you would get a 0.125, a 1, a -3, a positive 17. So what's the highest value? This. That's your absolute max, 17. What's the lowest value? -3. That's your absolute minimum. This problem here, this kind of sneak peek into next unit, unit 6, but we can still try right now. Looking at the graph of f prime, we can identify a relative extrema at the x-intercepts. So the x-intercepts are, right here, right here. Can you find the x-coordinate of the absolute maximum and the absolute minimum? Absolute maximum and the absolute minimum. So, remember, whenever f prime is greater than 0, f is increasing. Whenever f prime is less than 0, f is decreasing. You can think about your starting point right here, -3, right? You see how I shaded the green as the values for which f prime is greater than 0? So you can think about this green area by how much a function increases. It increases by this much area. Then it decreases by this much red area. Then it increases by this much green area. So you can see that your starting point, you increase by a lot, you decrease a bit, and then you increase a bit. So the question is your absolute max at x is equal to 1 or x is equal to 4? Because you see at x equals 1, you're increasing a bunch, and then you decrease, and then x equals 4, you're increasing a bit too, right? But if you see here, this red area is less than this green area here. So you're increasing by a lot, up to 1. You're decreasing a lot, and then you're increasing less than what you decreased for. Therefore, your max is at x is equal to 1. And x is 4 is not your absolute max. So your absolute min here is either going to be, well, let's see, your other two options are -3, your start point, or at x equal to 3. Again, at the x-intercepts are potential, and the endpoints are potential, absolute, max, or mins. So you're starting here, then you increase a bunch, and then you decrease, right? But this initial area that you increased is less than what you decreased for. So your starting point at x is equal to -3, your very first endpoint, is actually where your absolute min is. You can go ahead and start the practice for this.